Hello. What I'm doing here today is I'm gonna show you how I replace thermal fuses and maybe show you some tricks um, here and there on how to replace a thermal fuse in a fan motor. All right. So what I have here is a Lasco box fan motor. This particular unit's from 2011. From the date code on the capacitor here. So, first things first, where your thermal fuse usually is, it's going to be connected to your common and one of the leads coming off of the capacitor. So you'll need to look in the general area where this is, and you'll see the common wires coming out of here. But yeah, since it's a Lasco box fan, they use zip ties to hold their motors together. So yeah, you're going to want to get inside of here and be very careful peeling these off. You don't want to go ripping them off because you do have winding leads on here, right there, on both the leads of the capacitor. And what you're looking for is right there, inside of that little white tube right there. That is a tube made of fiberglass. It's basically heat resistant tubing. What you want to do is kind of like break these old heat shrink tubings up a little bit, and then sometimes you can just pop them off like that, but other times you have to cut them off. But of course you still want to be very careful and mindful of the winding leads there. And I recommend doing this outside of the fan, of course. Get it out on a table, or you could just lay it out. You don't have to worry about messing with the rest of the fan or nothing. And also, you don't want things dangling off of these delicate motor leads here. You want to be as gentle as you possibly can with that. Actually, I didn't need to take the tube off that one. So I'll just put that one back. Like that. But yeah, you want to get these tubings off of the ends of the thermal fuse here. And here's what I normally put inside of these. Since these tend to fail without any sort of notice or anything, I like to go with a 130 degree C fuse, and I normally get these little square ones. They're cheap. You can buy them in bulk. I don't like to use these little tube ones. So what I normally do is I find where that fuse is, and I cut it along with the tubing in half. And the reason I do that is because this tubing is actually kind of expensive. Or at least when I've tried looking for this stuff, this tubing is actually not very cheap. So what I normally do is I just cut that in half. Right at where the fuse is. So I essentially cut the old fuse in half right there. And then I've got 2 leads of tubing for this guy. But this is what okay, so this next bit is what I would normally do. Is what I would normally do if I were doing this without soldering at all. So what I would do if I wasn't soldering is, of course, cut the ends of the fuse off. But I would take this, put those tubes over the ends of this, and then with those tubes in there, bring this as far in as possible, and then I would twist the leads together. Matter of fact, I think that's how I'm going to do that for the purposes of this demonstration. I might have another motor I could show soldering, like actual soldering, but I'd have to go digging. But what I would do if I wasn't soldering is I would put these tubings on here. Yep, like that. And like I said, I would bring this as far up as I could, and I would twist those together and fold them over, and then crimp them with a pair of pliers, just for added security. And then I would go back over that with a new piece of heat shrink tubing on both of these ends. So that's how I would do that. But you know, I think I am going to go ahead and just do that. It's like I really want to show the soldering stuff too. Alright, I guess I'll go ahead and just solder it. I think I've explained that part enough. So yeah. Alright, we're back. Sorry if you hear any like fan whirring noises here on top of my computer at the moment, so bear with me here. So yeah, got the fan, the motor right here. So what I'm going to do is I'm going to take the old leads off using the iron here. Now this lead came off of here, so what I'm going to do is I'm just going to wrap this back on here. It's the lead going down into the motor. Now if that lead comes off and you don't know where it goes, both of the leads coming off of the motor, they go to the capacitor. They don't go to this, the common lead. That's just an in case that ever happens. But yeah, same thing as earlier. Put the tubes as far in there as possible, and then you wrap these around the legs here, and I'll show you what it looks like up close here in a second. But I leave just a little bit of play in that, so that I can do this next bit I'm about to show you. And then the other lead. Wrap this around here. Okay, so here's what I was talking about. See, I wrapped this little lead here. Yeah, like I was talking about. This little lead here came off. That always goes. These leads here, they always, both of them, always connect directly to the capacitor. And what I was talking about here is leaving a little bit of slack on this tubing here, so that you can move it around on both of these. I wrap these around. This is the common lead right here, and that is for this next bit. Now you want to bring these all the way up, as far up as you can. I normally like to leave a little bit extra, a little bit more slop in there, but this is what we're working with. Okay, but yeah, I just got the ends wrapped around there, and here I'll show you the next bit here. Just prop this up here real quick. Hopefully you can see what I'm doing. Okay, for this next bit, you can get yourself one of these little cheap little soldering things. You can get them from like Harbor Freight or Home Depot. Get them online, what have you. But you really just need the little metal clip that it has. And if it has protective tubing on the end of it, take that off. You don't need that. In fact, it'll hinder this next bit that I'm going to show you. So the next thing you're going to want is some aluminum foil. You're just going to want a little piece of aluminum foil like that. Now what you're going to do is, with the exposed ends of those leads there, what you're going to do is you're going to fold this up and kind of wrap the ends of the wrap the fuse with it a little bit, and then put the clip over those exposed leads right there. Now what that's going to do is work like a heat sink, so that you don't melt the fuse trying to solder this in, because that's the main thing you want to try to avoid when soldering in a new thermal fuse, is melting the fuse with the soldering iron, because then you'll just blow it. it'll be bad after that if that happens. But yes, so the end of the fuse is on the other side of the clip. This is clipped to the leads that are wrapped in that have aluminum foil touching them. You got to make sure the foil is touching those leads. And then you get your soldering iron. This is just a soldering iron off of Amazon. This is a lot better than the one that you get at like Harbor Freight or whatever for like $6. It's a lot better than that. It heats up way quicker. And this was like $20 6 years ago. Now you can get them for like $7 or $8. It's an okay iron. I would advise getting not getting the one with the screen. But yeah, this works pretty well. I've used this thing a lot. It needs a new tip already, but yeah. So now what I'm going to do is solder the leads on. So I'm gonna bring you back over here. In fact, I'm gonna get my sponge. Get my proper sponge and clean it off. It's better. And there's the leads all soldered up. Very quickly done. Just the rosin core stuff. Basically has flux already in it. And essentially that's done. And now you want to let this sit for a couple seconds. Feel the ends here, make sure they're cold before taking this off. And now that that's done, you want to test to make sure that there's a continuity across that fuse. Make sure it's still good. So you could just do a normal, an ohms test. And what you're looking for is a very low number if you're just doing that. If you're using a meter that doesn't have a beep function, so you want to test the leads. You got to make sure it's that it's not touching both ends of your skin. You got to make sure both ends are not touching your skin. Otherwise it'll mess up the reading because you yourself are conductive. Now you see that? Oh, come on. Trying to show here. There you go. I don't know if you can see that, but it's reading 0.8 ohms. But you're looking for 0.8 ohms. It's a little difficult because you gotta get a really good connection in order to read that if you don't have a beeper. But yeah, 0.8 ohms, very low resistance. That's what you're looking for. That means the fuse is good. It's not open circuit. But this demonstration, my meter has a beeper. and I can test immediately. Beep, 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 beep. Yep. And basically, that's the hard bit done. Now I just gotta put some heat shrink tubing on it. Now I don't. Now when I put heat shrink tubing on, I myself will become the heat sink. You'll see that here in a second. For keeping this from blowing. So here's the next bit here. So I use a hot air gun, a heat gun. I don't like to use any kind of fire or anything in here. So this is what I use, and it works fantastic. So I've got my heat shrink tubing here. We want to get a piece that will just fit over the soldered ends there. And I don't need that much, so I'm going to cut this in half actually. And I'm going to fit those over the soldered connections. I'm going to bring these fiberglass tubes up as close to the fuse as I can. Put those over. Now what I'm going to do is I'm going to put my thumb and index finger over the fuse to protect it. Use the low setting of my heat gun. Just heat that tubing up. Connections are made. Now it's time to button this all back up here. I'm gonna need a make sure I know where the capacitor comes out. I've done hundreds of these, but I still need a reference of where this cap comes out sometimes. So right there. Takes some moving around to get it in there. Good. There we we go. It is now in. Now, got that folded over basically how I want it. Basically what you want to do is you want this fuse to be relatively close to the winding. You don't want it all the way out, like out here or anything, because then it's going to be useless at that point. But you also want to make sure that the wires stay well clear of where the rotor will go, so that they don't rub against that. And then I like to go around here. Sometimes there's a little bit of there's this paper stuff that they use in manufacturing to hold the windings together. Sometimes a piece of that sticks out and it can rub on the rotor sometimes, so I like to go around and clean that up. But since this is a Lasco fan, and they use zip ties, normally I would go back with a zip ties, but for the purposes of this demonstration, I'm going to use what you would normally use, and that is some Kevlar cord. You could also use nylon, but essentially you just want something that's heat resistant. And then I like to use a bit of super glue with this, and I'll show you how I tie this up here. So you get a piece of Kevlar cord. I normally go about maybe 3 inches, because I'm gonna wrap around this twice here. So I'm going to thread this under here. No, I didn't. It ain't quite long. It isn't quite long enough. So I guess I'll just do one. It's not that important that this needs to be crazy tight or anything. In fact, most of these Lasco fans, you'll see that over time the zip ties just kind of break down. They get all crusty. Most of the time they'll just fall off when you open the motor up the first time. But yeah, I like to just do like 1 knot, maybe 2. I pull it as tight as possible. Try to hold it in place, and then I take my super glue and I do a little dab on the knot. I do a little dab just on the knot. You don't want it anywhere else. Just on that little dot there, and you want to hold it there for a second. Actually, I've got some extra lead here. I'm going to wrap around here. Create a second knot here on top of it. And there we go. Done. That is now done. Thermal fuse installed. You want to fold these down, make sure there's not going to be any like ends of the of the wiring that are going to touch the housing. And now this motor should work just fine. Provided this cap is any good. I have no idea. The fuse was bad in this particular motor. Yep. Bring this over. Pop it back together. All right. Alaska box fan. Here's what I do. Little dab, well, a big old blob of oil, and then I soak the wick around there before putting the rotor back in. I'm gonna clean this up real quick. All right, I'm gonna get that cleaned up and then put this back together and demonstrate it working. All right, I've got the motor cleaned up and all back together. Oiled the front bearing. Sometimes when you're putting these motors back together, or basically all the time, this will bind up a little bit. And what you got to do is the bearings are out of alignment, and what you need to do, just give the shaft a couple of taps like that. Sometimes you need to do it a bit harder than that, but in general it's fine. But I got some oil in there. It's all cleaned up, good to go. There's the repair right there. I've got it wired in, plugged in here, and I'm gonna flip the switch here and the motor will kick on. There it is. Now what are we drawing? Keep in mind this motor is not under load or anything. 0.77. It's running beautifully. And I'm standing in socks on concrete and I'm not getting shocked, so that's good. It means there's no short to ground or anything. I call that a success. Plenty of power. Alright, well, that's going to conclude this video. I hope some of these I hope some of these tips and tricks that I do and have demonstrated here will be helpful to anybody who is looking to repair one of these motors. Of course, not every motor is the same. Of course, everyone will have their unique challenges, but I think in general a lot of the stuff I've demonstrated here should be helpful to those. And yeah. Anyways, that concludes this. Thank you for watching.